So hello everyone. I hope you've been well. So today we're going to have a continuation on where we stopped. Last time we had a discussion around ERD diagrams. We tried as much as possible to do an exhaustive explanation there, but I also still believe that there could be sections where people really didn't quite understand it well. So I will quickly do a quick recap, and then I will do a continuation where we shall add on what we had to cover next. So the plan is simple, and we are going to just jump right into it. The plan is to just come up with a dummy database that looks at courses. In simple terms, we shall not be doing a lot of complex stuff where we have a lot of relationships. So we shall have a few relationships that we can still handle and then get to understand how this can come about. But before that, we shall quickly do simple designs for this. So what we have here is we shall look at a course. You can consider a course as a degree that you are taking in this case. For instance, let's consider it that way. Let's say you are doing a bachelor's in information technology or computer science or information systems or anything else in between there. Then you consider quotient to be any quotient you do within a given year. So we shall not go down into the details of how we can implement this when you look at some of the applications that you work with. But we shall try to understand in simple terms of how you can come up with a simple system in that regard. Then we shall look at users, which will comprise of lecturers and students. And then we shall see how we can represent a student or how we can represent a lecturer in this demonstration that we're going to do. So without wasting time, we are going to start with designing a quick ERD. But I'm working with a tool called draw.io, and I started with a quick template that they provide, and that's what we are going to adjust to have our end, like this to be fully represented. So what we have here, we're going to start with the course, and I'm going to just quickly move to that tool, and then we shall see how it works. So we are now here at that tool, and we are going to see how we can implement this. First of all, we are going to add, just given that I told you I just used the template, so I'll call this courses. And then as you saw what we had there, I'll call this course ID. Please just note that this might not be somewhat how you can do it and in an enterprise application, but given that this is for learning purposes and I would want everyone to be in position to follow, so we shall do it this way. When you look at what we have here, we have the course ID that we've just represented, then followed by the course name. So what we see here, this is like the column that we shall be creating, then the column of type character, and we expect maximum 50 characters if you are inputting data like this. So the purpose of this, first of all, is it's an informed decision that should come from you as you are designing your software. How much data you need to keep in a specific field, and that brings about is a management, and also it helps you to save some space as you are developing, as you are managing your database. So the next piece is the course description. So we take a copy of that, come here, drop the course description. I don't like the way it looks. Let's just write the word description, and I might want this to be a description to be maximum. Let's say maximum 100. So we can work with that. Let's quickly adjust the table so that we have everything in the view. Then the last one, we can consider the course duration. So the course duration for this case can also decide to say course duration for this case maybe to be represented as an integer, which can represent, let's say, months or something else, or a year. You might say we might remove the not null constraint to see that whoever will create a course, they can decide to not put the years for that duration, but if they put, then the system should be in position to accept that. And then we have that. Moving on, we are going to just do a quick duplicate here. Let's have another table here. And this table, we are going to call it, let's consider course units. So that is the name. When you look at this, we have the quotients. I see they appear down here. So the quotients have the quotient ID. That's what we shall start with. Shall say course unit, excuse me, ID, which we can say is a big integer for our case. Then when we go back, we have the course name. I think that is a course unit name. So the course unit name, then we shall have it here, course unit name, which can be a type of character and can also be 50. And we say it is not now. So we can remove this until we reach a point where we're going to understand it. So when we go back, shall see that we need the user ID. The user ID here. So the user ID, we shall consider it to be, let's say, also a big integer, which will not be null. We shall understand soon why we need it. But you realize that this is an FK1 that we are going to quickly also understand. So then the next one is course ID. So now we shall have here a course ID is also not meant to be null. For our case, the way we are designing it. And the last one is the quotient duration. So the last one is a course unit duration, like so. We can say it also a character on our end. It might not be a character. We can put it at an int and we say it is not null. Then we remove this. We are going to quickly understand why we have these and why are they important when you are designing. So the next table we can look at is a table of the users. So when we come to the users table, we can have it here. We can change this and we call it users. So the first thing we shall have is the user ID. Then the other piece is the first name, and remove this. First name is a character, which we can put at 50 as well, and we say it can be empty. And the other one is last name. Last name, we can also say it is a character of 50, and say it is not null. Then the last piece here we need is a role ID, which can consider to be an integer, and we are left with one table to do so far. When you look at our plan, we have a table called rows, which so we can convert the orders to rows, and then shall have this to be the role ID. Then we shall have the role name here. So say this is the role name, which is a character, maximum we can say 50, but it's up to you how big you'd want the biggest record to be. So this can be a character of 100, and I will move the date data type. So it is at this point, I remove this, it is at this point that we are going now to do a quick reorganization to really understand. So we understand that a course as a course, let's say computer science can be there without students, without lecturers, without even course units. That is okay, because the school or the team can sit down and be like, let's create a new course called computer science. So then we understand that the course can be there first. So it means that the course will be created first. But then when the course gets created first, you see that for them to be able to create course units from our design, it requires that there is already users. By users, I mean lecturers and students. It could be that students might not be there, but it could be that lecturers are supposed to be there. In our simple scenario, there has to be at least one user belonging to a course unit from our scenario we are looking at. So that is the reason why you see that we have a user ID. So it means for someone to be able to create a course unit, they should have a user ID in here. Which user ID will represent, in this case, let's consider that it represents a lecturer who will be teaching this course unit. So what you see as a user ID in here, you can even decide to say lecturer for it to make more sense. We can call it the lecturer ID. And it means for the question to be created, it requires a lecturer. That's why you see we have the FK. The FK stands for foreign key. Then we say foreign key 1, so it means there is another foreign key in here in our table. So we say the first foreign key, which will represent the lecturer that will be teaching this course, is FK1. So it means for you to have a course unit in place, it means you need to have users, which users will represent lecturers and students, and then you can attach a lecturer to a course unit. So in this case, the highlight then would be that you need to first have users. After you create the courses, you need to have users before you create the course units. Because we've established that for you to have a course unit, you need to attach a lecturer that will be teaching this course unit. So it means you need to have users before you have course units. Because how else will you attach a lecturer minus knowing that there is a lecturer in the users table? The next piece is we have another FK2. FK2 represents the course ID. As you remember that we have courses here, so it means if you are creating a course unit, you need also to have a course where you attach this course unit. And then it means you can't have a course unit minus having the courses. But as well, you can also have, you need also to have users. Maybe one more thing I think we need to have in this place is that we can as well add some interesting piece here to represent the course that it can be the student that they belong to. But for this case, I believe this might make it a little bit harder. So let's remove it for this case. But as you design your system, you could find that there is a need to have a course attached here, let's say for the students, but it might not be the case for the lecturers because they might be teaching in different courses. But with our simple implementation here, let's keep it simple as it is, and then we see how it works. But then you realize that as we've created a table that only takes in users, we don't care whether you're a lecturer or you're a student, because today you might be a lecturer, then tomorrow you become a student, or tomorrow you're a student, the next time you become a lecturer. It can happen on both ends. So to keep our system flexible, we've decided that then we shall only switch your role based on at the point when you've maybe transitioned from a lecturer to a student or from a student to a lecturer. And then we've decided that we only need your first name, your last name, and then your ID. What do you do? So then that forces us now to create another table called the roles table. So within the roles table, we have now, I think this is not supposed to be there. We have now the role name and the role description. And it means for you to have users, because we've said not null, which means that it has to be there. There is no way we can now have a user minus having the rows. So it means we shall create the rows first, then we shall create the users, then next, as we are going to see. But also as well, we could decide that a quotient can belong to only one course. So if that is the case, okay, we shall have that as a discussion at a later stage. Let's just keep it simple and then we go on. Let's drop that. Apologies. So let's work with what we have because it might complicate things. But now here we are going to learn now about a very interesting concept. You will see that we have a line here that moves from courses to roles, and what it represents here in what we do here is the cardinalities. It is like the cardinality, which represents how the flow is. But this is wrong because I was using a template, but now I'm going to start attaching the cardinalities and show you how they work and how they make sense. So first of all, what I'm going to do is I'm going to move this here. I will move the users a little bit down here. Then I will move the course units here up. Then I will move the rows down here, and I will put this here, somewhere here. Then I'll have my courses somewhere here. So let's now understand how the cardinality will work in this case. So you understand that for us, and that might call for us to really switch this a little bit. To prevent the overlaps, then we shall have this to have a lecturer ID. So what we are going now to represent is that we are going to see how now we can represent cardinalities so that even if we give out this design, ERD design, then another person might be able to implement our system, our schema, so to say. So what we have here, we have a course. So the course appears first, but then to create a course unit, you need to have a course ID. So for us to represent this, we can do it the way I've just done it here. That now what this says is that one course, which can be computer science, can be attached to a couple of course units. So it means that we can have multiple course units belonging to a single course. So we can have a lot of course units, but still belonging to the same course. So the representation now will be that one course, which is represented by that one slash here, can be attached to a couple of course units. So many course units can belong to a single course. And when you see a 0 appearing here, it means that it is not a must. So it means that there can be a course, let's say, or computer systems as a course, which is a bachelor's of computer systems. But then you find that they haven't attached any course into it, which is okay. That is why you have this kind of representation here. It is not a must for this case that every course that gets created should have a course unit at the time of being created. That is what the 0 represents. And then the other 3 lines then represent that it can be that this course can appear in multiple course units for this case. So that's how you represent it. Now let's do the same representation here, where we find that one role can be attached to multiple users. You could find that you have more than one lecturers. So we've done it, we've just replicated what was there. So we are saying a single role can be attached actually to multiple users. So you could find that multiple users are lecturers or multiple users are students. So that's how now we are representing using the same representation that we have here. And please note that that is very key if you want your system to be used by other people, or even to get more people to support you in the development. The same thing that you'll find that now a single user can be a lecturer of many programs that are happening out there. So you could decide and you say, okay, now what we have is that a single user can be in position to teach multiple courses. So that's what we are trying to represent here. I'm trying to adjust this to appear. Okay. Yeah, I think now we can see the lines very well. It might not be the best representation there is, but it gets the job done. So this is a simple representation. If someone looks at this, you should be in position now to understand how the cardinalities work. So this is the simple one that we are going now to implement in our database. And we see how it works, then we also put in some data and get to have a feel about this. So we realize if we apply this kind of constraints as they appear here, you find that for us to be in position to create these tables very well, what we shall need, we shall first need to create the course table, or first of all the role table, but these two should be created before. Then we can now create the users table, and then we shall create the course unit table. Otherwise, we can't create the course unit table because it needs to have the course ID as well as the lecturer ID. My bad, this is meant to be the lecturer ID. So if you try to create this table, you find that you get an error because it will ask that it looks for a user table that doesn't exist. So we are going to see that in a minute now, and then we shall put in some data. So let's move to our database tool. First of all, we are here. The assumption is that everyone should be in position to have the database already installed on their machine, a database of preference, most preferably an SQL database. That can be MySQL, Postgres, Oracle DB, or MS Server. So any database that is an SQL database. So for me, I will demo using Postgres. If you find challenges looking up on how you can install MySQL Postgres on your machine, please feel free to reach out. Then I will be in position to help. So first of all, we are going to create a DB. I'll right click here and then I will say create database. So I'll call my database, I'll call it learning management. So after creating this, you assign a user. First of all, here I will just use the Postgres user as it appears. Then I'll save. Okay. So now when I save, you see that a database called learning management has been created. And in Postgres, to be able to see whether you have tables, you come down to the schema. When you come to the schema, you go to the tables. And once you open the tables, you can even refresh, you'll see your tables here. But as you can see, we don't have any tables here. So what we are going to start with, first of all, is we are going to create our first table. So I will right click here, I'll go to query tools, then it will open query tools. And what we are going to do is we are going to, first of all, going to comment and get to understand the first table that we are going to create is the courses table. And what do we have in there? Let me quickly check it out. We have the course ID, then we have the course name, then we have the course description, then we have the course duration, which we are saying it is an integer. This is a character of 50. This is also a character of 50. So there is what they call a primary key that you use in your table. As we shall understand at a later stage in Postgres, this is of type serial. So what we are going to do now, we are going to create that table. Given that, as you see up here, the query tool I've opened is within my database called Learning Management. So I don't need to specify where this will be created automatically. Postgres knows that it will create it from here. So I'm going to write now a query that will create the table. So I will say create table. Then I will call this table courses. And after that, I will open brackets. So inside the brackets, I will now specify what I want. I will say, first of all, I want the course ID, and the course ID is of type serial. And I'm telling Postgres that this is a primary key. So now it will know that it is going to use this as the primary key, which means that it can generate it out of the blue as you are trying to insert in data. So now the next one I'm going to do is the course name. And the course name, we are saying that it is a character in Postgres. We represent a character by saying varying character, varchar. Then we are saying from our design that it shouldn't be empty. So we are saying not null. Then the other one is course description. And within the course description, we shall have the varchar as well. Voucher, how you say it. So please note these ones can be also written in small letters. Still, Postgres will understand, or any other SQL database that you are working with, but usually it is preferred to have them in capital letters to be able to differentiate them from those that are not commands that speak to the DB that you are using. So now, if I run this query, you see that we shall have the table created. So what I'm going to do here, I'm going to come to this, which says execute, and then I'll execute this. And down here, you see I have a successful, it says create table, query returns successful in those milliseconds. So now, when I come here and I click, I won't see anything. But if I refresh now, you see that now I have my table created here. And if I click on this table, then move up here to this arrow where it says view data, I will be in position now to see my table created. And as you can see, I have now my table created, and my table has course ID, course name, course description, and course duration. So that is the table we've just created here. So now we can see how quickly from this table we can then insert some data. We can decide to say now, okay, let's first insert some data, and we see if we have a course that we would want to record. So what I will do, I will just quickly comment out this, and then I will get to the top here, and I'm going to put in some data. Then we shall go back and refresh and see that data. So the command is, we say insert. If you are inserting data in a table, we say insert into, then the name of the table. As you recall, our table is called courses. Then after that, we open these brackets and we specify which fields we want to put data into. Remember, I told you that course ID, Postgres will automatically generate that, or any other database that you are working with. So I will say we are going to put data into the first name, the course name, then the course description, and then the course duration is optional. So we are going to see in the next record that we shall put in. We shall say here course duration, and then so when we have this, then we can put in the values here. That is the next piece that we have to do. So now it will mean that the first course name will take up this, where we can say BCS. Then the description we can say, I think we need to use small single quotes. Description will say this is a Bachelor of Computer Science. Okay. Then the duration is 3 years. So if we decide now to run this query of inserting, you see that the query ran successfully, and it is telling us here that insert 1. So it means we got some data in here. So if I now click here and try to go again to view, you'll find that we have this created. So it has an ID of 1, BCS, Bachelor of Computer Science. Then we have a duration of 3 years. So now let's add in one more, actually 2 more data. So what we shall do here, then we shall insert more data in here. We shall create another course, which can be BIT, sort of information technology. Then we can decide that this one won't have a duration. So we can even remove the duration because it is not a master's, you see. We are saying that it is okay if it is not given. So if you execute this query, you see that it returns successful. And if I try to look at my table once more, you find that now I have a Bachelor of Computer Science, but I don't have now the duration for that, for how long it will run. So moving on, when we are doing an insert, you find most of the times that you can even put in more data at the same time. So let me just bring my course duration again. And I will create another one that is information systems. And I will say, okay, this is 4 years, but still, so when we run this again as well, you'll find that we shall have this created as well with 4 years. So if I check again, you see that we have another one. So all the records that we have here, we have 3 records, but we are basing on the design, which says course ID, course name, course duration, course description, course duration. So you can have as much records as you want, but they're all conforming to the initial design that you put out there. So what we can do now, we've been placing this icon to see that data. But now what we can do is, how can we select our data programmatically using Postgres commands? So we can do select. We can do select star from what is the name of the table from courses, and that's it. If you run this query, it will go and select all the data. The next thing you see, you have all the data here. So this is how we put in data, which we call the create. Then this is how we select data. So you can start practicing something like that. But as well, the other piece is that we can also decide to update. So how do we update? You realize that Bachelor of Information Systems does not have a duration, so we can decide to update that. And how do we do that? We shall say that update. So when we are updating, we shall specify the name of the table. We shall say update courses, and then we shall use a keyword called set. So when we say set, now we are specifying which field we want to set. We can say our course duration, and then when we say course duration, we shall say, okay, for that we shall give it 3 years. But then how will it know? Because if I run this, you'll find that all the course durations here will be set to 3 years, but we don't want that. So now this is where we use a clause called the where clause. So we say where, now we're specifying where what. So we can say where course ID is equal to, if you look at here, you will find that BIT is course ID 2. So we shall say course ID 2, and we want only to set that. So when we run this query, you see that it returns a success. So if I now run this query again, the lower one, and you see that BIT now has been updated to have 3 years. Yeah. So that's how we can also do an update in our tables. You just run, you put a condition. If you don't put a condition, you need to be very careful. If you don't put a condition, problems will happen. And what are the problems that will happen? You find that you have a database of over 1,000 users or even 1 million users, and you update without a clause which is a where clause to specify which records you want to update, you'll find that all the records are updated, and then it might become a problem because sometimes you didn't even intend to update all those. So now, as we wind up this, let's create one more record here. We can call our course test. We shall say maybe Bachelor's of Testing Systems, and it is 4 years. So now we are adding this new record on our list. And if we do this and then come back here, highlight this query and run it, you see that we have now a record called test. But then at a later stage, you might realize and be like, we don't want that record. So it is better we delete that record. How do we delete that record? Because not every now and then you have access to a tool like this that can show you your database. So, but you can go into any terminal if you have access to that database, and then you'll be able to write a query. And the query will be, you write delete. So you specify where you're deleting from, then you say I'm deleting from courses, where. So now you specify what do you want to delete, what is the condition that you are basically going to delete. Because if you don't specify a condition, you delete your entire database, you delete your entire table, and you don't want that. Because you might delete 1,000 records from users. How will you then tell them, okay, please sign up and create your accounts again? It can't happen. So you have to have a where clause. Never run a delete or an update minus having a where clause. You can run a select, you can run an insert without worrying so much about that, but an update and a delete always have a where clause for the condition that you would want your query to look at. So here we are saying where course ID is 4, because we've established that that is the course ID for the test course that we've just created. So if I run this query, it is successful. So now if I go back, run the select again, you'll find that that record has gone. So in simple terms, that's how you do an insert, that's how you do an update, that's how you do a delete for all the things that you would want to delete from your system or create or update. So we've just created one table and we've seen all the commands. So when I'm working at a later stage, I won't have to go through this again. So what I'm going to do is I'm going to just move on, and then I will create the next table, and I will clear this space so that I can be in position to create another table quickly. Which other table are we going to create? So we realize that we need to have the courses first and we need to have the rows first. So the next table I'm creating is the rows table. So what I will do is create table, and the table we are calling it rows. So what do we have in the rows? We have first of all the row ID, which is a serial. Am I writing serial right? I don't think so. Is a serial, and I'm saying this is a primary key. This is a primary key. So the next piece is row name, which is a varying character of 50. Vowcher, please note you might find that vowcher doesn't work in your database that you are using and they use characters. It is okay, you still have the job done. So you might not stress about that when you find that it doesn't work with your choice. But if you use Postgres as I'm using, then all these commands should just work fine. So now this is also not null. So when you run this query, it will create for us now a rows table. And if I now try to refresh again, you see that we have also the rows table created. And in the rows table, we can quickly insert data as well in the rows table. So first of all, what I will do is I will just bring back my insert for the courses, and I will change this to be rows. Then in the rows table, what we have is we have the row name and the row description. So this one we can delete. So we are looking for two rows. First one is student. learning from course, like that. So we can run this. Then the other one is, which I'll have now, the lecturer teaches. So the lecturer teaches the course. So we can also run this. Very fast, you can test even the other one, the other queries on this very table, which is still okay. But I won't, so I'll leave that up to you to test it out. So then I'll clear this, and we are going to create another table very fast. So that table we are going to create now is going to be, as we noticed when we are starting, what we said that there are some dependencies, but how we are at a good step, because now what we are going to do is we are going to create but we have to start with the users, as you can see. So we are going now to create the users table, and please pay attention to the users table that we are going to create. You'll find that we need the user ID. So we shall change this to user ID. Then the other one is we need the first name, which is also varying character 50. We need a last name, is also varying character 50. And then we need a role ID here. So we need a role ID, which you realize that it is an ID that we pick from. We shall be picking from another table. Which table is that? That is the rows table. And we are saying it is not null. So how do we then enforce this? Because if I run this table and I create it, it will get created, but it doesn't mean that it will be there and it will always try to check. I think we can change this to a big integer, that it will be there to always check whether the row that is being assigned to a user exists. It won't check that. So there is a way we can enforce that it should always first confirm that that role exists in the rows table before it is assigned to a user, as we are going to see. So now, how do we do that? We use also a special keyword here called references, and then we put the name of that table. So we are saying it is referencing the user table, and it is referencing the user ID from there. So wait, nope. Nope. So what we are saying is that it is referencing the rows table here. Yeah, it is referencing the rows table, and it is referencing the role ID from there. Apologies, because if you see from our table, it has the role ID. So what we are doing is that the role ID we've created here in the users, if I remember right, we have a role ID here. So the role ID that we've created here in the users table should always check, when you are creating a user, it should always check that the role you assign to a user already exists the other end. Otherwise, it won't create this user. And this is the word references, and we say references role ID. Role ID. This role ID you see in the bracket is this role ID we have in the roles table, this one. But what we have here in the users table can change. I can even update it for others to understand. I can just call this role user ID, but just no role ID is fine. But you can even call this anything you want, provided you have the right column in the other table that you have in here in the brackets. This doesn't matter the way you call it. So if I run this query now, it will create this table for me. And as you've seen, it has created a table. If I refresh now, you see that I have the users table. If I now open the users table, you see that it has the role ID here. But how do we then test this? Let's try to quickly create a user. I will pick still some of my existing queries, and I work with that, and we see how we can create a user. So we are going to first start with, I think, a lecturer quickly. So we shall say insert into users, and then what are we inserting? We are inserting the first name, then we are inserting the last name, and we are inserting the role ID because it is required. You can't create any user without having a role ID. First of all, the not null enforces that you can't create minus having that. Then as you create, then we reference now, this is what we call a foreign key. If you see, that is what FK stands for. And the only way you can enforce a foreign key is by using the word references. And then you pass the table you are referencing and the column you are referencing from that table. So now I'm creating the first lecturer, and the first name I will call them John. Then the last name I will call them Doe, like John Doe. Then I will give them, I won't care. I think we created 2 records in there. We can quickly confirm from the rows table. I remember we created some records in there. We can quickly confirm. We need to know the ID. We are making them lecturers. So lecturer is ID 2. So now where I am here, I'm going to give it an ID of 2. And then I'll create this first user. So when I create this first user, that user goes in. If we come and check the users table, you see that we have a lecturer called John Doe with an ID of 2. Then let's create a student quickly. So we are going to just update this and we say, okay, let's call this person Jean, maybe Jean Jones, Jean Jones, and we want to make them a student as we realize that the student ID is 1. So we also have a student now. If we come back and look at the users table, you see that we have now Jean also created. But what if we would want to create some other person, let's say Jack, Jill, and then we would want to give them an ID that doesn't exist, like for that doesn't exist in the rows table. What happens? Because we have a reference here that enforces this. Will this record be created or it won't? One way to do that, let's find out. So if I send this record, you see that it says error. And down here it says insert or update on the table user violates foreign key constraint. Users role ID foreign key. So details, key role ID 4 is not present in the roles table. So it means each ID you put here should be in the rows table. So it means the rows table should exist first before you create a user table. I think now it makes sense. So we are running out of time, so let's move and then create the last table. And our last table was now the course unit. So when you look at the course unit here, we shall say course units. So when you look at the course unit, we have the course unit ID, the course unit ID, then we have the course unit name, course unit name, which is also, I think, a varying character of 50. Then we have the course ID, which is an integer, but I think we can change it to a big int. It is a big int. Then we have another one is you remember this is going to reference as well. So what is it referencing? It is referencing the courses table and it is referencing the course ID from there. Then when we look at then the last one is the lecturer ID, which is also a big int. And what does it reference? Now it references the users and it is referencing the user ID from there. I hope now you understand when I do references. So now the last one is course unit duration, which is an integer. We say it is an integer and we are saying not null, like this. So now if I try to create this table will get created. You see that we have that table. If I refresh, we have now this table here. And if I try to open it, you see that it has all these fields. Now we are going to try to put in data here. So quickly, we are going to do an insert into this table, and we are going now to insert a course unit inside this course unit table. So what does it need? First of all, it needs the course unit name. Then it needs the course ID. It needs the lecturer who will be teaching that course, and also needs the course duration here. So now we shall say, okay, the course name, can call it operating systems. Then we need the course ID. So when we talk about the course ID, that means the program, let's say computer science, what? So we need to come here and say, okay, what are we attaching it to? So we are attaching it to BIT. BIT is ID 2. So there is no way you can attach it to a course that doesn't exist. So let's attach to BIT. So we shall set 2 for the field of course ID. Then the next piece is the lecturer here. So which lecturer are we assigning this course unit? So let's look at the users table and find a lecturer. It can be, right now it doesn't care. You can even use a student for that case. But given that for us, we want to work with a lecturer, and I remember we looked into the rows table and realized that a lecturer is ID 2. So now we shall pick this ID 1 that belongs to John Doe as our lecturer. So now we shall put it here, and then the last one is the duration. So we can say, okay, this is meant to be 6 months. So now we are creating our first course unit. It says column course unit of relation user does not exist. Okay, now this is an error. So I'm trying to insert into the users table, yet I'm supposed to insert into the course unit table. So it shows in the error that you see down here. So now let me run it again. So now it says it has worked. So if I come to the my course units and I load this, you see that I have these records in here created. It is very good. So now I can add maybe one. Yeah, actually, let me add like 2 so that I call it programming. Still, I'm adding it to the same course BIT, still the same lecturer, and I'm saying maybe the duration is 4 months for this. So I run this quickly. Then I'll do another one. I'll say this is now Java programming. The course this time I will change. I'll give a 1, which I think is like computer science, and the lecture will stay the same because we have a single lecturer. So now it is also 4 months. I run that. Then the other one is C++ programming. I'll give it to the 3, that is, I think, information systems. I set the lecture to be that one. I'll give it 5 months, and then I run this record as well. So I might add now one more to show that there is we can get an error if I try now to put a course that is not in our system, and I run this. It will tell me course ID 5 is not present in the courses table. I hope now that makes sense. So I think quickly I can pick this, and then we go into the final step of now returning our data and have a look at it. So how are we going now to really go in? Because you've seen when we looked at all the tables, they are just full of IDs everywhere. So if you want now to send this data back to a user, let's say the user has requested for some data, how will you do it? If it is only full of IDs, will the user understand the IDs? Of course, they won't understand the IDs, but now that's what we would want to solve. So how are we going to do that? We are going to quickly look at a simple scenario. We are not going to go into complex stuff until maybe we start now working with this in our projects. That's when we shall go into some details that are a bit tough. So we are going to make it simple. So now we are going to, our scenario would be that we would want to know what course unit a course belongs to. Let me see. I think, yeah, would want to know what course unit. Yeah, we would want to pull the course units, and then we get to understand which courses are in there. So first of all, let's first return all the course units. So I will say course units like that. I'll run this query. You see that as they return, they just have IDs, but I don't want this. So I would want to know what courses do these staff have. So I'm going to try it now, a simple query here. I'm going to say select star from courses. So this is what I'm going to run now. So what I'm going to run now is, I have now the courses here, but I would want now to know the course units. I get the courses together with their course units. So how will I do it? So in SQL, we have what we call join. If you want to write it fully, it is called inner join, but I'll abbreviate to join. So I will say select from courses, and then I say join. So what am I joining? I'm joining the course units. So as I join the course units, what do I want to join on? So you specify what you want to join on. So I will say I want to join on courses dot course ID. So what I'm saying that go into the courses and look for the course ID. For every record here, look for its course ID. So now when you find its course ID, then go into, this is the on. I'm saying I'm joining the courses. I'm saying courses, I join as well with the course units, but I'm saying on what condition should I join? So I'm saying join on course ID, where the course ID is equal to the course units dot what was in there in the course units. When we ran it, let me quickly check that. Where do we find the course ID in the course units? We find it on the course ID column. So now what I'm going to do here, I'm going to say we are joining on also the course ID that is available in the course units table. So when I have such a query, if I have such a query, then I'll be like, go into the courses, first select all the courses, then go into the course units and also bring the course units, then try to join them on this condition where this ID in the courses is equal to the ID in the course units. And then you find that we have Bachelor of Information Technology, and we find that the operating system belongs to Bachelor of Information Technology. Then you also find that linear programming belongs to Bachelor of Information Technology. And then we find that Java belongs to computer science, and C++ belongs to information systems. So you've seen that we've gotten all the data from both tables, and you find that BIT appears twice because it has two course units. If it had one, then it would appear once, as you see these other ones. So that's how you can try to pull out data so that the user then can know. And we can go ahead now to reduce on the data that we return, because you find that most of these pieces won't make sense to a user. So how do we do that? Then we can say that given that course ID here and course ID here are the same, so how do we then tell our query that we only need this course ID. We shall pick courses, but course ID, we put it there, then we add a comma. We say, we can say now course name because course name appears once. And then we might need the course description as well. We shall say now course description. Then we can also bring the course duration. Then now we come to these ends of the course unit ID. So I will drop this to a new line quickly so that it is more readable. So now what do we hunt here? So the course unit ID also is unique. It doesn't appear in both tables. And then what else do I need? I also need the course unit name and maybe the course unit duration. So now if I run this query, it will still come back, but it won't bring those IDs that I won't understand. It will only bring the data I need, but I know that it is returning the right data. So as you can see now, it has reduced the size, and then all the data that I'm seeing here, I need it. If I don't need any column, I just come here, remove that very column. So that's how now you can do meaningful data that you can return. As an exercise, because this is where I'm going to close it, I would urge you, given that the course unit table has also the lecturer ID, go in and also add a user in this column so that we understand which lecturer teaches which course unit. I think that's it. Thank you very much. And I wish you a lovely weekend. So, yeah, see you until next time. Have a good day.